I think there is a better system that we can use, I have actually went through and I've done some mathematical calculations to figure out what dates I think we should be using and what dates we would actually be spending the most amount of days in each zodiac, because right now the tropical dates, they are saying that you are born in, like, let's say Gemini, but we are actually, based on the IAU boundaries, in Taurus, not in Gemini. And for some zodiacs, the whole time that the tropical date is in that zodiac, you are never in that particular zodiac, you're in other zodiacs. So I find that the tropical dates are the furthest from being true when it comes to the ancient belief system that we need to be in a zodiac based on what zodiac is on the opposite side of the sun. So I have gone through and done calculations to figure out, based on the IAU boundaries, which day and how many days we are actually in the proper zodiac, and I have set my dates for my calendar for each month based on that. Now, 12 zodiacs everybody knows about. Everybody knows about the 12 zodiacs. What people don't know, and this is the one thing that irritates me heavily, is every astrologer should know that there is actually 13 zodiacs. There's not 12 zodiacs. And the reason that there is 13 zodiacs is because there is 13 constellations that are on the north and the south side of our ecliptic plane. Not 12. 12 is what we use for our year, but there is actually 13 zodiacs. Now, 2 zodiacs are actually fairly small zodiacs because they overlap each other, and the IAU boundary dates are short with those 2 zodiacs because of the fact that they're overlapping. And those 2 zodiacs are actually Ophiuchus and Scorpio. So Scorpio's IAU boundary dates, when you're looking on Wikipedia, are November 23rd to November 29th. So that's only a 6-day window for Scorpio's boundary dates. And that's because Ophiuchus cuts off Scorpio's boundary dates on November 29th, because that's when Ophiuchus actually crosses the ecliptic plane, is on November 29th. So then Ophiuchus is across the ecliptic plane until December 17th. So Scorpio has a really short period of time, even though it's not a small zodiac, there's a very short period of time where its boundary crosses the ecliptic plane, and Ophiuchus actually crosses the ecliptic plane because Ophiuchus is a really big constellation. It actually crosses the ecliptic plane for way more days than Scorpio does, because Ophiuchus goes from November 29th to December 17th, where its boundaries are actually across the ecliptic plane. So when I did my dates, I wanted to do dates for 13 zodiacs, not for 12 zodiacs. So not only did I want to take the days and average them out into 13 months, which is very easy to do compared to the calendar system that we're using now, and lots of the calendar systems in the past were a lot more complicated. My calendar system using the 13 zodiacs, because there is actually 13 zodiacs, and every astrologer should know that there is actually 13 zodiacs. I don't know why most astrologers, which is the science part of the zodiacs and the constellations, I don't know why they most of the time won't admit that there's 13 zodiacs, why they won't talk about it, but I can guarantee you there is 13 constellations that cross the ecliptic plane, and astronomy proves that. So if anybody is actually serious in knowing about the zodiacs, if anybody is serious about horoscopes, they all should know, if they've done their studies, that there is 13 zodiacs, not 12 zodiacs. So I can provide pictures for my boundary dates that I have set for all 13 zodiacs, because of the fact that each constellation is a different length and a different size. 28-day months will not fit perfectly into every zodiac, because like I said, some zodiacs are only 10 days long and some zodiacs are 40 days long. So fitting 28 days perfectly inside is impossible. So the sidereal dates are trying to average out 12 zodiacs for 30 or 31 days in length. My system is doing 13 zodiacs for 28 days, because 13 zodiacs at 28 days works out to 364 days perfectly. Our year is 365.25 days. If you follow my 13 zodiac calendar of 28 days in length, you're only left over with 1.25 days at the end of every single year. And we already have a day that's called New Year's Day, so you can still have that one day be New Year's Day. It just won't fit under any of the zodiacs. But the one particular day that I have picked for New Year's Day is actually in the zodiac of Sagittarius. And then every 4 years, because our year is actually 0.24 something, however many decimals long. It's not actually 0.25, it's 0.24876 or something like that. So because it's not exactly 0.25, right now every 4 years we add a leap year. And some of the leap years we miss because our year is not actually 0.25, it's 0.24687, whatever the number is. And because of that, you have to skip some leap years, because putting a leap year in every 4 years works out well, but it doesn't work out perfectly. So some of the leap years we actually like to skip to keep us closer to a perfect solar year. So we could still add that one extra day every 4 years and still skip the years that we want to skip, and still stay in line with our orbit around the sun. Now, the one thing that you're going to realize as I'm going through my information is the precession of the equinoxes actually changes our seasons, and I will get more into depth about how it changes our seasons and why I think it's the largest thing that changes our seasons. And that whole precession of the equinox mixed in with the tilt. So the tilt of the Earth is also known as the Earth's obliquity. You can call it the tilt or the obliquity. Our obliquity ranges from 22 degrees to 24.5 degrees. So right now we suspect, based on astronomy's calculations, that our tilt right now is supposed to be 23.4 degrees. But every year we're supposed to be decreasing in our tilt. So I figured out that based on how many years it takes us to tilt, that it's roughly a 20,520 year cycle to move 2.5 degrees. So with us being at 23.4 degrees right now, by the time we get to 23 degrees, since our degrees are decreasing every year, we should reach 23 degrees at approximately the year 5303 CE. So that's what I have calculated based on the information I've been able to find on how long it takes our obliquity / the tilt of the Earth to change. And everyone needs to know that the North Pole is not exactly where our obliquity is. So we have a point on the Earth that we use, which is the North Pole, for our obliquity, but that is not necessarily where our magnetic north is. Our magnetic north actually gravitates and moves around in the northern part of the hemisphere, and it never sits perfectly on the plane that we would call our obliquity plane. But it does migrate around it, but I don't think it usually ever sits exactly on it. So because of that, we actually end up with two different spheres around us. So just how the Earth has a grid system wrapped around our Earth that is associated with our equator, we would also have a grid wrapped around our planet based on our ecliptic plane, and we would also have a grid wrapped around our planet that is associated with our equator because of the tilt of our Earth, but it would project from Earth into the stars, and then we would consider that to be our procession of the equinoxes ball, I guess you could say. So there's two different balls. One ball is based on our orbit around the sun, and one ball that encompasses the Earth is based on the rotation that the Earth takes in a 24-hour period. So with my calendar, adding a day for the extra day that's not in the system, and because we have to add an extra day for a leap year every 4 years roughly, skipping some, I think my calendar system would be a much better calendar system, because we wouldn't have such a chaotic calendar. Like right now, some of our months are 28 days, some of our months are 30, and some of our months are 31, and I mean, they just oscillate around all over the place, and that makes it very difficult to keep track in any particular way, because a lot of ancient peoples used to use 12-month calendar, so they would use 12 zodiacs, and they would do 30 days in length, so that would only make a 360-day year, so they would have 5.25 days every year. Like they would literally just wait the 5 days to start their new calendar, and some ancient societies considered those 5 days to be unlucky or unholy days. Because of our Earth's tilt away from the sun or towards the sun, depending on the particular year. So at this current moment, when we are at the furthest point from the sun, the northern hemisphere is actually tilted towards the sun. So the northern hemisphere has its summertime when we are at the furthest point of our eccentric orbit. But the reason it is summertime in the northern hemisphere is because the tilt of the Earth is toward the sun. So I have a graphic that shows that our winter solstice is when the northern hemisphere is pointed away from the sun, and the summer solstice is when the northern hemisphere is pointed towards the sun. So the day where the sun and the day on Earth is the longest, that is the summer solstice day, and the day where the northern hemisphere is pointed away, so the sun has the shortest day, that day is the winter solstice day. And then we also have the spring equinox and the fall equinox. So the equinox is when the Earth is actually pointed not towards or not away from the sun. It's actually pointed parallel to the sun. So in the fall equinox, the Earth is pointed parallel to the sun, and in the spring equinox, the Earth's tilt is pointed parallel to the sun. And we mark those days because they are halfway in between the summer solstice and they are halfway in between the winter solstice. So the reason our seasons change slowly in the northern hemisphere, we can have one year that's hotter or colder depending on our eccentricity. So if our eccentricity happens to be where the Earth is pointed towards the sun, but we are at our closest orbit to the sun, obviously the summers in the northern hemisphere would be hotter than what they are if it's pointed towards the sun and further away. So because the northern hemisphere is pointed towards the sun, when the Earth's at its furthest point from the sun, that is why we have the temperatures in the north that we have right now. But if you go 13,000 years from now into the future, the Earth will be pointing in the exact opposite direction that it is pointing in right now, which means in 13,000 years, when we are at the most eccentric part of our orbit, our Earth is actually going to be pointed away from the sun. So we get our winters in the northern hemisphere when the Earth is pointed away from the sun. Then that means happens when in 13,000 years, when we are at the least eccentric part of our orbit, the northern hemisphere will actually be pointing towards the sun. So the summers in 13,000 years are going to be much hotter, and the winters in 13,000 years in the northern hemisphere are going to be much colder. And the reason is because when the Earth is tilted away from the sun, I have a graphic where it shows the sun rays coming in, and the reason the hottest point of our Earth is around the equator is because that points directly to the sun and is closest to the sun all the time. So when the sunlight comes through our atmosphere and hits the equator, it is hitting the equator in a much more tight pattern than what it does when it hits the northern hemisphere. So when Earth is tilted away from the sun, not only does that light get spread over a larger area, but it gets spread over for a shorter period of time because of the fact that the Earth is tilted away. So no calendar system that we have had in the past or that we have right now really takes into consideration the tilt of the Earth, because our seasons do migrate throughout the year. And I don't know if you've realized this, but in the northern hemisphere in Canada, we used to not be able to plant crops until after May long weekend of any given year. Now it gets nice enough out before May long weekend that if the temperatures are ideal, you can sometimes plant before May long weekend. But sometimes before May long weekend, we still get a little bit of frost, so you will sometimes still see farmers wait until after May long weekend to plant. But we used to have to wait sometimes till April to plant our crops because the weather wasn't good enough until April sometimes. So you can already see the migration of the seasons in the northern hemisphere because of our tilt that we have on Earth. And that's because in the last 100 years, our tilt would have slowly changed, plus our precession would have also changed. And because our precession is a 26,000 year cycle, we only move so many degrees in our precession every single year. So like I said, in 13,000 years, the northern hemisphere seasons are going to be completely reversed, and no calendar has ever taken into consideration that I know of that aspect. So I think that's been enough for today. I don't know if I've completely explained things that make sense to anybody. I will also provide a picture that will show how our stars have slowly changed and have slowly migrated over the years. The one picture that I have is of the Big Dipper, and it shows you what the Big Dipper's shape was in the past, what its shape is today, and how that shape is going to change in the future. And the reason that changes is because not all of our zodiacs suns stay in position relative to each other, because as astronomy tells us, we are orbiting around a black hole in our galaxy, and the planets that are closer to the center of the galaxy actually travel faster in relation to the speed that we're traveling on the outside. So if some of the suns that we see in our constellations are closer to the inside of the galaxy, they are going to move and change the way that our zodiacs look if they are suns that are being used for our zodiacs. And that's because we are traveling at a different speed in relation to that particular sun or solar system or whatever it is. So with that being said, thank you very much for watching my video. I hope I clarified some of this stuff. I will do another video in the future that will provide more evidence and hopefully make things even easier to understand when it comes to the fact that we have 13 zodiacs rather than 12 zodiacs. But thank you very much for your time, and I hope you have a great day.